Heat engines perform different tasks, such as producing work, cooling or heating, storing energy, and possible additional conserved quantities, such as particles with deposit. The application of the basic concept of thermodynamics to machines can support and facilitate human work, highlighting that currently the vast majority of mechanical and electrical energy consumed in the world is generated through a combustion process. Although still well decided, there are also other renewable energy sources. Generate fluid with high thermal energy that is transformed into mechanical energy in a high energy biofuels, solar thermal energy and geothermal energy.
One of these is the so-called hybrid. Sun is performs or more than one takes simultaneously. This allows to obtain a great performance in terms of efficiency because among states is the production of work, the temperature variation, and therefore the loss of multiple energy resources. For the correct operation of a thermal machine, as is the case of reactors, an external heat source is required, and to obtain it, the generation of fuel gas is needed, which can be given from biomass from coal gasification, medium water gas, and methane.
Heat engines are devices that convert thermal energy into mechanical energy. They use a heat source to generate work. Internal combustion engines and external combustion engines are examples of heat engines. External combustion engines work with burning fuel. The combustion include turbines, gas turbines, and refrigeration cycles. The efficiency and performance of thermal machines are crucial for the reduction and emissions of gases.
What's heater needs? They are a device that combines thermal energy into mechanical energy doing what they see nanometers the guardi variation applique the perfect heater modes determining in navigate Charlotte is called 18th century mass chinion the thermal energy generated in the gateway the consume called to Duce sit Titrons sumus without sumus caving and energy mechanica works currently that Darwin does that the nine dove chat internal combustion the nines firlins.
The thermal machines require an important characteristics of the fluids with which they work from their operations. And this is capacity of storage and release of energy thanks to the compression capacity that they possess. Science machines have both open and closed systems. The fluids will experience different change in each one. For example, in a closed system, the fluid does not involve significant energy losses,
which is why it could be classified as reversible. However, heat losses though they support an error, but in an open system, the fluid moves at high speed. Fluid is stayed inside the machines is short, so the process can be considered irreversible and adiabatic.
Thermal machinery performs multiple tasks. For example, it is responsible for deriving energy. It is also responsible for providing cooling. There are hybrid thermal machines that perform more than one task. Will form a quantum thermal machine. The working medium is a harmonic oscillator. Quantum connect to treat heat. Fat can also be used as a high performance transistor, driving it of single output to input and different gain at the same time. Heat engines are efficient, which means they can be used is two ways, how in the power model and the current to change it is only necessary to modify the frequency.
In short, thermal machines are mechanical elements that perform work torque cycle process conducting energy related to load with the principle of thermodynamics. The global behavior of different systems are understood subject to expansion understanding process with turn this reversible and reversible theory in meaning the function of states. When talking about a thermal machine, these are of the great importance in with respect to the development of industry. These are related to work, heat, and energy extracted to the decay or occurred in reversible process.
Ultimately, every heat engine will go through a performance called thermal efficiency, what compresses heat input and work output. Every heat engine must waste a certain amount of energy by transferring it to a low temperature reservoir to complete the cycle. All this can be understood thanks to the second law of thermodynamics. In the same way, all these concepts lead to an impossibility of building thermal machines that has an efficiency of 100% by the effect of energy variability throughout the thermodynamic cycle of the machine.